This is the question. Question is that the sphere is of radius, a solid sphere is there, and it is a certain radius and rotating with the angular velocity about the diameter. So it doesn't matter that it's about the diameter because the sphere is identical in shape, so it is rotating, and whenever it is rotating, it is always about the diameter. Then the sphere is rotating over a table and having a friction, and the friction has a friction coefficient mu. At what time the slipping is observed? So it is want to know the time where the slipping is observed. Okay. Now what to do? So this is the sphere having some weight. Since it has weight, so weight is always downward. So it is W is downward, that is weight, and radius of a sphere is r. So if the radius of sphere is r and weight is downward and it is moving in the moving toward x-axis, the x-axis is along this, is over the table and having some friction. So due to that friction there is a frictional force, and that frictional force is in this direction. Okay, so this is what frictional force. Now what to do? We know what is torque. Torque is I alpha. Now always whenever the torque is there, the angle is opposite to the torque. The direction of angle is opposite to torque. For example, the angle we measured from here, and it is opposite to the torque. Okay. Now, so here I will apply the negative sign. Now what is torque actually? Torque is what? Frictional force into distance. These are perpendicular to each other, so I write this as Fr. F is what? Frictional force. And now what is moment of inertia? I don't know the moment of inertia, but we have already solved the moment of inertia for solid sphere. Solid sphere moment of inertia is 2 by 5 m r square. No need to solve here for the moment of inertia. Just remember the formulas of the moment of inertia that I already told you. And what is the alpha? Alpha is theta double dot. From every time I already told you, omega is theta dot and alpha is theta double dot. So from here, if we try to solve the concept for omega, then what we got, that frictional force is nothing but minus 2 by 5 m r square theta double dot. Fine. Now what is F? Frictional force. Frictional force we know mu into n. And n is always normal, is always upward. Normal is always upward. So it is n is equals to W, and W is equals to mg. So can I say it is as mu mg? So frictional force is mu mg. Mu mg is equals to minus 2 by 5 m r square theta double dot. From here m get cancelled out and we remain with the formula that mu g is equals to minus 2 by 5 r square theta double dot. So this is what we got. Okay, now mark this as equation 1. Clear? Here again mg is downward, and since it is moving with the angular velocity omega, and this force it is moving with a force F. This F is now different. This is not a frictional force. This force is just an accelerating force, that is translation, due to the translation, because a sphere having a rotational as well as translational motion. So this force is due to the translational motion, and that is what we know, F is equals to ma. So we know again torque is equals to I theta. I alpha. Torque is equals to I alpha, and which is also minus. If I solve this, is going to be the F into R, and which is going to be the minus I theta double dot. Now what is F? F is a force, a translational force. Capital F is a translational force, which is F is equals to ma, and I is already told you 2 by 5 m r square. If I put these values, so what I got, ma, and can I write a as x double dot? So m x double dot is equals to minus 2 by 5 mr square and this theta double dot. So this m is the mass of the sphere cancelled out, and we remain with a simple thing, that is x double dot is equals to minus 2 by 5 theta r square theta double dot. Now what we will do, we will integrate this to find the velocity. So for velocity for velocity integrate. So for velocity, if we integrate this, what we got is going to be x double dot is equals to minus 2 by 5 r square theta dot minus some constant, and that, or plus some constant, and that constant is something we say omega. Okay, so if you see this, or this constant is something not omega, the take you can see as k. Okay, k is a constant. I'll tell you what is k here. Now there is a velocity that has responsible for body to be rolled or sphere to be rolled, and that velocity is what v is equals to omega r. Fine, this is what v is equals to omega r. Or can I write this as a different way? I can write this as v is equals to omega r can be write as x dot is equals to omega, it's r theta dot. Fine. Now as you know already that x dot is minus 2 by 5 r theta dot plus k. Fine. Now since we have angular velocity given, that sphere already has an angular velocity, and that angular velocity is omega. Okay, so this k is nothing but 2 by 5 r omega. Fine, k is nothing but 2 by 5 r omega. So x dot is equals to minus 2 by 5 r theta dot plus 2 by 5 r omega. Why I am saying this k is going to be the 2 by 5 r omega? Because since the velocity is there, angular velocity omega is there, so due to that omega, the sphere is moving with the velocity that is the due to initial velocity. Because of particles, if a particle is at certain translational initial velocity, then we know v is equals to u plus at. Similarly here we know it has a certain angular velocity, that is omega, and due to that angular velocity it has certain what we call, it has certain angular velocity also, translational velocity also, and that is what 2 by 5 r omega. And because it is a sphere, so this is 2 by 5 r omega. And if we know, if we put the value of x dot is equals to r theta dot here, so I put the value r theta dot, which is equals to minus 2 by 5 r theta dot with plus 2 by 5 r omega. So r get cancelled out from each and everywhere, and if I shift the theta dot to the right, then I got it as 7 by 5 theta dot is equals to 2 by 5 omega. And from here, if I want to find the theta dot in terms of angular velocity that is given, this is what I got, theta dot as 2 by 7 omega. Now what is this theta dot? This is the angular velocity with which the sphere is rolling. Okay, this is the angular velocity with which the sphere is rolling, and omega is the angular velocity given to the sphere to start rolling. Okay, and this is the velocity or the angular velocity which with the sphere is rolling, and with any time, means as a function of time. If you want to find the angle varies with a function of time, then you can be able to find it by using this concept. Now comes to same thing, that is what we want to find, that is what time at the point of contact for slipping. As we already found that mu g is nothing but minus 2 by 5 r theta double dot. I already find this. Okay, now what to do? Just integrate this, and we got as a mu g t is equals to minus 2 by 5 r theta dot. Okay, plus same thing, that is what 2 by 5 omega. This is what the constant. that is k, and k is constant, I already told you. This is what 2 by 5, oh sorry, it's r omega. So it's r omega. From here, if I put the value of theta dot, that is 2 by 7 omega. So if I put the value of theta dot, can I find the other things also? So what I will do is 5 by 2 mu gt over r. Fine, and we remain with minus of theta dot plus of omega. And if I put the value of theta dot here, that is 2 by 7 omega, so it's going to be 5 by 7, I think. So it's 5 by 2 mu gt by r is equals to, if I put the value, it is 2 by 7 omega plus omega, and so minus sign, so 5 by 2 mu gt by r is equals to 5 by 7 omega, and 5 is get cancelled out, 5 is get cancelled out, and we remain with the time in terms of omega that is already given, and it's going to be r, it's r over 7 mu g into omega. So this is what also 2 is there, okay. So 2 r omega, this is what I got, the time period, or simply a time, and that is the time of the contact where the sphere starts slipping, where sphere starts slipping, because I applied the condition. Why, or what condition what I applied? The condition is that v is equals to omega r, isn't it? So v is equals to omega r condition is applied at the start of the, that is what we know. The condition was for rolling condition. Rolling condition was v is equals to omega r, or x what is equals to r theta dot. Same thing, I applied this condition to get the time period and also the angular velocity of the sphere with which it rolled. This is what the certain question we have done, and we will see one or two more questions in next lecture also. Thank you.